Greetings and welcome to your experimental demonstration. The experiment that we'll be conducting today is to observe the effects caused by the water coming into a regulating pond on its bed surface. A model has been constructed based on the regulating pond of Pergau hydropower station for the use in this experiment. The Pergau hydropower station is located 125 kilometers from Kota Baru, the capital of the state, Kelantan. At this site, they observed damages to the pond floor through bed erosion and linear rupture downstream of the apron, due to which the owners, TNB, appointed University Technology Petronas to do a comprehensive investigation into the causes of damages and design of the rehabilitation works. Thus, the Pergau pond model was constructed to do a core investigation of the damages. Before you is the model that we'll be using for the experiment. In this model, the baffle blocks as well as the bed floor of the pond are an important parameter that were contributed to the failure. Therefore, the size, shape, and also the arrangement of the baffle blocks as an energy dissipator are main factors affecting the bed floor condition. Now, what is a regulating pond? A regulating pond is a temporary storage facility for watercourses like streams. When the discharge from the dam is directly into the watercourse, it might potentially overwhelm or even cause flooding. In order to avoid this, water can be stored into a regulating pond. Some of the uses of a regulating pond are that it can be used as a extra storage from the dam. It can prevent damages caused due to overflowing of the reservoir or even prevent flooding. It can be used to study the erosion in the reservoir or even act as a model for studying sedimentation in the dam. Now let's move on to observe the construction of the pond. At the inlet site, the section is made out of sand and gravel. This is used to observe the erosion caused by the inlet flow. The pond is constructed at an slope so that a flow is created towards the discharge. The water from the pond is discharged from these points. These outlets are controlled by gates which can be opened or closed. Here you can observe the construction of the pond on the inner side. So let's move on to observe the different components that make up this model. This is the pipe that brings the water into the model. It is attached to the pump that delivers the water from the storage tank. Here you can observe the inlet mouth that is opening inside the pond. In front of those you will observe the different baffle blocks. There are two rows of baffle blocks of different kind. In the inner layer you will observe a row of standard baffle block, while on the outer layer you will observe two staggered rows of cuboidal baffle blocks. There are two sets of outlets that can be observed in this pond. The first outlet is situated at the toe of the pond, through which the water at the base of the bed or at the bed can be discharged. The toe discharge is controlled by this gate, which can be lifted up or down based on the level of discharge that is required to be outputted from the pond. The second outlet is located at the head of the pond. This outlet ensures and regulates the head of water in the pond and avoids overflowing from the pond. The second outlet is also controlled by these gates, which can be moved up or down based on the level of discharge required, and the water is then drained out through these pipes. The water stored in the overhead tank travels through these pipes and is then distributed into the main pipe, which carries the water towards the model. This is a control valve. It is used to control the rate of water inflowing into the pond. So now let's move on towards our experiment. We have leveled the sand in front of the inlet and let the water flow into the model. As the water flows into the pond, you can observe the hindrance caused by the baffle blocks and the dissipation of energy can be observed. The water filled inside the pond is discharged through this outlet. Due to this, a flow has been created inside the pond. As the flow has been created, you can observe that the sediments or the sand travels throughout the flow from the inlet where it is situated towards the outlet. In order to observe the erosion pattern caused by the kinetic energy of the inflow water coming into the pond, the depth of the indentation caused will be measured, and the distance between the mouth opening and the erosion pattern is also measured. The section in front of the inlet was divided into three sections. The depth of erosion at point 1 was observed to be 3 centimeters. At point number 2, the depth of the erosion caused was 5 centimeters. And the observed depth of indentation at point number 3 was 4 centimeters. A different pattern of erosion can be observed when the inflow rate is changed.